Okay, like heck, I'm going to stop now just when things are getting interesting. So, we have changed the object calculation function, which is what tells the object what to do, from returning a new version of the object, which means it can only change itself, to returning a set of changes to make to the world. So it can add, remove, or make fairly arbitrary alterations to anything in the world. We could just have it return a copy of the world itself with whatever it wants to do done to it, but I don't know. Anyway, so we need to create a few functions that will take a bunch of add, remove, and alter changes and actually apply them to the world. In case you haven't noticed, we don't do many loops, we don't even do much recursion. Most of what we do is iterate down lists of things, which is generally what you use recursion and loops for anyway. There, that's pretty easy. OCaml has a pretty good set of list iteration operators, so removing something from a pile of objects is a bit trickier than adding it, but still well within the realm of a standard library function. I forget. Okay, so filter takes a function that returns a true or false and creates a new list containing everything in the old list that that function returns true for. So everything not equal to the thing we're removing, and that's pretty much it. Eventually we're going to have a data structure better than a list for this, hopefully. Maybe, maybe not. It's kind of awkward no matter what. And then we could implement an alter as a remove and then an add. I'm not sure if there's really a better way of doing it, though. Yeah, we can't mutate it, so right. Alter is a pair of objects, the one we want to change and what we want to change it to. So can just remove it, the old one, add the new one, and that's it. List fold left, basically it's irritating to explain, but it does an operation once for each object in a list, and it preserves state, but it passes state between it. So for instance, here G is the game state, and it gets altered with each call of the doAlter function, and the next one gets passed to the next invocation of the doAlter function. So this is actually fairly easy. So we have we've collected all the changes from calculating over the list objects, and we just apply them to the game state. And the order in which we do this matters. So let's see, we will first remove objects, then remove old objects, add new objects, and then alter objects. Okay. That should work. Except for a couple issues. One, the player is not in the list of objects, which I think it's a bit of an irritating problem, because we need a reference to the player in specifically because the player does a lot of unique stuff, but we also want it to be treated just like any other object. And have the same a lot of the same calculations done to it, like drawing and calculating new positions. So we have it as a separate object in the game state, but we will tack it on to the list of objects that we calculate just before. Actually, we can but then this makes the player yet another special case, and there's one thing OCaml sucks at handling its special cases. But we'll worry about that in a second. Input, that's another thing we'll worry about in a second. But let's see if this compiles. Of course it doesn't. Partially because I've just sort of commented out a big chunk of it. And let's see. Okay, we'll comment out a bigger chunk of it. There's some stuff we have to change in the game state, like the timing and so on, but we can do that sort of ad hoc. And we just won't worry about the input for the moment. 148 syntax error, or 184 syntax error. Ah. It's on 218.